Hi everyone, this video is about practical implementation of simple linear regression. Let me import NumPy and pandas. Let me load salaries dataset. Here I have. Here we have the dataset. Let me check the shape of this. It has 30 rows and 2 columns, right? Let me get the head part. Here we have 2 columns, years experience and salary. Years experience means the experience in number of years and the salary that the employee get. Years experience is the independent variable, whereas salary is the dependent variable. And we need to find out the dependent variable, right? But this is a label data, as you know that. Let me get the complete data set and copy it in Excel. I have already copied this in Excel. Here we have. Before we apply algorithm, we need to do 2 things. One is separating independent variables from dependent variable. That is, this is independent variable. We have only one independent variable. If we have multiple, just separate as one data frame. Separate the dependent variables and store it in another variable. Let me copy this and copy it here. This is X, okay, and this is Y. This is dependent variable, right? Here we have independent variables stored in X and we have dependent variables stored in Y. Now we need to split it into 70-30 or 80-20 proportion. Let me separate this. Let's take this is 30%. Okay. I'm cutting it. Paste it here. Let me copy the columns also. As you know, this is X and this is Y. So this data set X and Y both, I'm going to make use it to train the algorithm. So we call this as train data set, right? After applying algorithm on this, we're going to get parameters and thereby we get model. So once we get the model, we need to apply on the test data set. We call this as test data set. Call it as test data set, right? In order to give a different name, here we have X and this one is also X, right? And this is Y and this one is also Y. So give a suffix to this, that is train. This is train data set, right? Just to differentiate each of these data frames. Train. This is also train. And this one is test. And this one is test. We apply algorithm on this. We get the parameters. Thereby we get model. Once we get model, we apply it on X-test data. So it will come up with its own predicted values. That is Y-pred. Once we get Y-pred values, we can find error and accuracy, right? Let me show that in Python. What we have to do, we need to separate this into independent and dependent variables, right? Salary, ILOC. So we have only one independent variable, that is years of experience. I'm going to fetch all rows and only the first column. If you check this, you got only years of experience. Store it in X, capital X. You can write even small x or any other variable, but the usual notation is capital X. And the next one is store the dependent variable in another variable. Y, salary, ILOC, all the rows, the last column. If you check now, X head, we have years of experience variable, and Y, we have dependent variable. Once we separate the dependent and independent variables, we need to split into train and test datasets. For that, we need to import train test split from scikit-learn model selection, import train test split. Once we get it, just apply try and test split and pass this both independent and dependent variables x comma y, and you need to provide the test size, right? Make it as 0.3. So test is going to be 30% of the total data set. So store it in 4 variables, like in this case x try, x test, y try, y test. This should be a sequence. You can't change the sequence. X try, x test, y try, y test. Yeah, here we got. Let me x underscore. Yeah, this is much better. We have splitted this into 4 different data frames: x train, x test, y train, y test. Now we can apply linear regression, I mean simple linear regression. There is a difference between simple linear and multiple linear regression. The difference is, if it has only one independent variable, like in this case we have only one independent variable, that is years experience, right? In that case, if you apply linear regression algorithm, it is going to be considered as simple linear regression. If you are going to have multiple independent variables, if you apply linear regression on that problem, it is going to be considered as multiple linear regression. This video is all about simple linear regression. That is why I have chosen a data set that has only one independent variable, that is years experience in this data set. Let me get the linear regression from scikit-learn. Linear model. This is where it is in. Import linear regression. And create an object for this. Here we have regression, right? Let me fit this against x test, try, y try. We have to feed both x try and y try, right? In order to get the parameters. That is why we use fit. We got the parameters. If you want to check, you can check it. Here you got the parameters. Once you get the parameters, you can predict it. Predict against what? Predict against x test. We have to supply this x test. We got parameters, we got the model. If you apply it on x test, we are going to get y pred. Then we can check accuracy between y pred and y test, that is salary, right? X test and store this in y pred. That is what we are going to get. Now we got y pred. Let's check it, what it has. It has some values, right? Let me remove this. Now try to find error and accuracy. To find error, we know that we need to import metrics, right? Which is part of scikit-learn. We have metrics now. We can calculate MAE, mean absolute error. We can calculate mean square error. We can calculate RMSE, root mean square error. Let's calculate mean absolute error, that is MAE. Metrics, mean, you can see you got mean absolute error. The parameters that you have to provide for this is y test and y pred. You can replace salary as y test if you have confusion. You have to provide y test and y pred. Here it is showing blank, right? I have not filled these values, but we already have the data here. If you want to check, you can check it here. Y pred. Here we have the values. Provide y test and y pred as parameters. We got MAE error. Let's calculate mean square error also. The same parameters. And root mean square is nothing but square root of this, right? Square root of mean square error, right? So just use NP method square root and copy and paste this. Here we got root mean square error. This is root mean square error. Now let me calculate score, that is variance score. We have used a very lengthy formula 1 by u by v, something like that, right? It is not necessary. Regression has a method called score. If you provide y test and y pred, it gives a wrong value. What you have to do is, you need to provide x test and y test. not y-test and y-pred. Okay, this is what you have to provide to get the variance score. What it does is, when we provide x-test and y-test, it is going to apply model on this x-test data, it is going to calculate y-pred, and it is going to apply it against y-test, and it is going to give the actual score. This is a fantastic method, right? I can definitely say this is a very good model because the value is 0.958, which is nothing but 0.96, which is near to 1. One more thing, that we don't have unlabeled data, right? If at all customer provides you unlabeled data, what you have to do is, we have the object, right? Just use predict and pass the data frame. That's all you have to do. Pass the data frame in the sense, you have to pass the set of independent variables. As this is simple linear regression, you are going to get only one independent variable. You have to store it in a data frame and you have to pass this here. If you pass this, you get y-pred. Predicted values. That concludes this video. If you have any questions, post it in Q&A. Thank you for watching this.